Hello everyone, welcome back to this channel. Before we get started, please hit the subscribe and the notification buttons below. It will help me measure the level of interest. So today I'm going to talk about one of many possible applications brought by my unveiling of the pen stroke storage within Supernote binary files. A quick reminder about pen strokes. For each page, the binary file of a .note or .mark file in the Supernote contains an ephemeral image that is used by many third-party tools, but also the native Note app. Among other things, it is used to output the results of the pen strokes in different formats, such as images or PDF. That image is temporary because every time you edit a page, the Supernote rebuilds it. The image is just an output of the pen strokes, meaning that without access to those pen strokes, you can't modify the useful content of the notebook. Essentially, you're limited to building applications that work one way, from the device to an exported format. You can re-upload a PDF to the Supernote, but your handwriting will no longer be editable. As far as I know, no one outside Rada's sphere has been editing pen strokes or creating .note files from a script before. I hope my contribution will help other developers in the community build more tools soon. All right, enough chit-chat, let's dive in. All right, let's start by showing a few output examples. I will then show you how you can replicate and customize them in PySN. First example. Here's a notebook about the topic of forgiveness across religions. You can see the quotes for each Holly scripture, the reference, and a small explanation. Those are real pen strokes. I can select them, move them, resize them, add links, etc. Some of these are too small, so let's switch to landscape by tilting the device. A heads up here, be prepared to tilt the device more often. Here is the .note file on my Supernote, and there is the source Word docx document. What can I tell you about that example? A few things. Anecdotally, the story behind this example. This specific text-to-pen strokes idea originated indirectly from a viewer's comment on a previous video. The viewer saw the pen simulation I made at the beginning of the video and wondered if it would be possible to simulate entire scriptures, as he often includes scriptures in his workflow. For him, having such a document would save a lot of time by allowing him to quickly navigate to a particular verse, select it, and paste it into his notebook, rather than writing out entire verses by hand. Unfortunately, the simulation as shown in that video is a very slow process, and building such a document would take a lot of resources. But the issue to solve moved along, and eventually a solution was implemented as a text-to-pen stroke feature in PySN. I kept the topic of religion to give him credit for initiating this specific application. The viewer also mentioned that other platforms like Books allow text insertion, but the text is inserted as a different embedded object. That solution was less appealing for him than real pen strokes. I took from his comments that ideally he would like to have the scriptures appear more like his own handwriting. Another comment. If you look closer at each letter individually, you'll notice that the letters are poorly calligraphed. In fact, they look like they were designed by a kid. Yes, my handwriting is horrible. But since the sentences are well aligned, and since the imperfect letters are consistently the same, the whole text appears legible, at least for me. So, what did PySN use to produce this notebook? A source file with some typed text, in this case a Word docx. The X is important because PySN won't work with older .doc file like natively produced from the Supernote, so make sure that you use the newer docx format. The content of that document is from GPT-4. Okay, so that was the first input parameter. Second input, an ASCII table in a .note format. What is an ASCII table? Glad you asked. I am simplifying here, but it's basically a table with letters that are sorted with their corresponding index number. So, I created a notebook using the standard grid template and started to fill it with some meaningful letters, following their index number order. In Note binary files, each pen stroke on a given page is represented as an object that includes a rectangle location on the screen and a vector of points. Also, behind the scenes, PySN knows where the table starts, how many elements are in a row, etc. You probably already see where we're going. The script gets the text, it creates a list of words, and for each word it reads each letter, For each letter, it uses its index number to find the coordinates of that letter in the table we provided. Since that table is a Supernote.note format, and since we know how to retrieve the pen strokes, we just need to identify in the binary file all pen strokes located at the coordinates of the letter being parsed. Then, the script combines these pen strokes by shifting them from left to right and top to bottom, as in natural Western reading order and yada yada. The advantage of this implementation is that you don't really need to know everything about pen strokes data structure. It's enough for us to know how to access and edit their location in the file and on screen. In other words, the ASCII table in a note format is a bridge between standard representation of letters and pen strokes. And the cool thing is that you can give this feature your own touch by editing myfonts.note. That's the ASCII table file coming with the latest version of PySN. Just quickly, another example of output. This time the source is the automatically extracted text from the highlighted sections of a digested PDF. So in a nutshell, you highlight some sentences, paragraphs of a PDF, you run PySN, PySN extracts the text and converts it into a notebook that you can edit or use as a copy source. We'll see that this conversion is automatic for every PDF that is in a digest path. And one last such PDF example. To illustrate how accents are rendered, here are some excerpts of a famous French book obtained by highlighting the PDF. From an information efficiency standpoint, using pen strokes to represent information is super inefficient. You literally have hundreds of points for just one letter, like this letter B, while representing the same letter with its ASCII code would take just 1 byte. But that's the inherent characteristics of these e-ink devices. What we gain at that cost is the ability to scribble, resize, create a meaningful layout with just a screen and a pen. Supernote will soon come with a solution allowing insertion of text and images. Do you think it's going to be like here with pen strokes? Please leave a comment below. Okay, let's see how we built these notebooks. First, you'll have to install PySN with a version higher or equal to 1.17 at the time of this recording. The link to the video for fast installation is in the description below. You may also need to browse other videos on my channel for more specific features. Not everything is most up to date, but overall, you'll get the idea. Just a quick warning for current PySN users, save your user settings.json and other customized keyword settings because the installation will erase them. Second, you need some source text files. Now by default, PySN assumes that the path to text files that you want to convert to notebooks contain the string text2 notes. There are also 2 other parameters to scale down the font size and add a left margin. Don't worry about them for now. In fact, I'm going to remove all these parameters to use the default values. All right, I removed almost everything else from my watched folders to keep just what I need for this demo. I'm already using the default settings, and I have under document a folder called text2 notes with a few files. One is a text file with copy and paste material from Supernote website. One is that Word docx on religion. We also have a few PDFs with highlighted sections, including one in French to illustrate accent fonts. Highlighted PDFs are an exception to the path text2 notes requirement. By that I mean that for digested files, the extracted highlights are always being converted to notebooks. However, remember that PDFs you want to digest have their own path string requirement that is by default digest in. Also, all exports go to the digest export folder, which in our case is the export ignore folder. Third, you need a notebook with the ASCII table. For now, the script will use the notebook named myfonts.note, located in the PySN Digest SN Vault folder. Okay, you can modify the contents, of course. My current tests using this table was a bit ugly, but a more professional looking table will come later. All right, it's showtime. The shortcut icon is back to black. We are done. Well, this was pretty fast. Let's see what we have. First, let's look at highlights extractions because the conversion takes place automatically. What do we have for exports? Per the settings, these are directed to the export ignore folder. And we can see that each highlighted PDF generated 3 files. A merged PDF, the equivalent of exporting the annotations. We also have the markdown file of the extracted text corresponding to these highlights. I have a previous video about that feature. The third file is a notebook. In the Text to Notes folder, we also see some new notebooks. Let's head to the PDF output folder on the Supernote. The preview of the new notebooks has a big warning sign. As we head to the Text to Notes folder with the non-PDF files, we notice the same type of preview. Let's open the notebook on religions. The message says that the page was generated by PySN and that it needs a refresh. It asks us to switch to landscape mode, draw and erase a dot on the top left. Is that a joke? Remember what we said about the still image? PySN created a notebook from scratch for us, but it didn't render those pen strokes. Technically, since we know the content of the pages, we could have created a temporary image and encoded it in the binary. But we want to keep things simple here, and we want the Supernote to generate the new still image. The problem is that PySN doesn't control the Supernote, so we need to trigger a refresh. Following these instructions, do create an internal refresh. Maybe there is an undiscovered byte that automatically trigger the refresh, but I haven't found it yet. So let's just follow these silly instructions. First, put the device in landscape. Like I did at the beginning of the video, I can just literally lift the tablet perpendicularly to the desk for a second and then put it back on flat. Second, we are instructed to write a dot and erase it. The erasing part isn't necessary, so I'm going to skip it. I don't mind the extra dot. Let's do it for the next pages. I can feel that this process is slow, probably because the Supernote is busy rendering suddenly a lot of data. Okay, it's done. Now to save our changes, let's use the back button to close and reopen, and voila, the changes have been applied to the portrait view and we have a fully functional notebook. Quick quality check. Let's open the source text file. It does look okay. These are real pen strokes, and selection, resizing, heading seem to work, but it's kind of ugly. Now let's tweak a bit some of the parameters that we mentioned before. Fonter is a font ratio that you can apply. I felt the need to reduce the ugliness of my fonts by scaling them down a bit. L margin adds a margin to add notes on the side and help selection. So let's rerun with these, using respective values of 0.6 and 0.8. As you know, PySN processes only modified files, so let me edit the source file to modify it a bit. So again, the files with the warning, landscape mode, dotting or dotting erase here, anything that actually modifies the contents, close to post those changes, reopen, and voila, we have margin where we can add our personal notes. As you can see, PySN reflowed the text. Now, let me reshuffle a bit to reproduce the file I was showing at the beginning. Let's take a look at the other source text files. Again, we need to edit them a bit for PySN to consider them. For the PDF documents, we will further apply keyword settings to visually create a distinction between imported strokes and true hand strokes. Here is a JSON on my computer called strokes-black-to-dark. And these settings will make PySN modify this notebook such that strokes that aren't size 0.3, my preferred size, nor dark gray, are going to become size 0.2 and dark gray. I found out that somehow my imported fonts have a size that is slightly different. So that's a cool feature to allow us to make a subtle distinction between imported pen strokes and true handwriting. Let's modify first the academic paper by highlighting a bit more. Then the same for the French novel and the text from the Supernote website. Launch PySN. Done. Opening the Supernote website import notebook, tilting, dotting all pages, closing and reopening. Now let's head to the PDF export folder and let's open the French notebook. Tilting, dotting, reopening, adding headers, taking more notes. then adding the conditional weight and color keyword settings. On to the academic paper, tilting, dotting, closing. Then editing with headers. Selecting words in the middle of a paragraph is possible because most letters are composed of one stroke only. All we need to pay attention to is to fully include all the letters we want. It doesn't matter if the lasso touches adjacent words. If the lasso touches partially some letters, those letters are not going to be part of the selection. Some notes on the margin, and the conditional weight color keyword settings. Now we're not importing text anymore, but to apply these settings, let's move these notebooks to the Demos folder. That's one of the folders in our input list. Let's run one more time, PySN. It's done. For these pen strokes modification, PySN creates a new notebook by adding a new .note extension because the changes are potentially irreversible and we'd like to give the user the option to discard the modified file. I realize this can be a bit confusing, especially because as of today, there isn't any warning yet about the need to refresh. So your clue to pick the modified notebook for now is to pick the file with the two .note extension. Tilting and editing is still required, but here we can just erase the dot we inserted earlier. For the Supernote, this is still a refresh triggering event, so proceed for all pages, close, and reopen. Let's do the same for Le Petit Prince. We now have notebooks with weight and color distinction for imported text. All right, folks, let me guess your most important question here. How do I customize my own fonts? Here's what I'd do. 1. Back up myfonts.note just in case. 2. Open myfonts.note and replace each character by your own handwriting. 3. Try to write a letter with ideally just one stroke. Why? Because it will use less space and make it much easier to select words with the lasso. Trust me on that. If a letter is made with just one stroke, the lasso needs to include it entirely for it to be selected. If it's composed of several strokes, then the chances to break a letter into pieces is greater. 4. The script works for writing top to bottom, left to right. So for languages like Arabic, you'd have to customize the code. 5. The script uses the Unicode decimal value of a character unless the character is already in a custom map dictionary. I included most current non-ASCII characters in that dictionary, but you may have to add your own. Look also at the char from ASCII TPS that uses the code of the first character, the length of each cell, the number of characters per row, etc. It should be obvious, but send me a note or ask the community if you struggle. 6. My experience is that after you are happy with the entire set, you have to select all and paste to a new notebook. 7. The script uses an intersection algorithm, meaning that it's not important to center the letters in a cell. What matters is that each letter is in the right cell. 8. Visually, what matters too is to have the same size of letters. As you can see in this French case, my A acute is too small. 9. Some characters need vertical position adjustment. There is a dictionary at the beginning of the code. Makes sense, right? You want your quotes to be higher and your dots lower. 10. Hopefully we'll come soon with a real universal font solution. Okay, friends, it's time to wrap up. Unveiling pen stroke storage in the Supernote is my most significant contribution to the community of developers for this platform. It opens many possibilities like conversion to other brands or even Office software, etc. But on the other side, it also makes my convoluted digest code obsolete. Indeed, if I had to redo it, I'd just move around some pen strokes instead of combining pictures. Let me know in the comments what your thoughts are about any application for your workflow. Don't be shy, the sky is the limit. In the meantime, happy writing.